an example of that is temperature, Fahrenheit, because a cricket's chirps isn't what changes the temperature, but the temperature changes how many times the cricket chirps. So that's going to be your independent, and that's going to be your dependent. All right?
Yeah. So, do I write degrees or?
Well, not just yet. This is just a point in which we can start at. So the first part is A. Write a particular equation expressing chirping rate C in the terms of temperature F. C and F, you don't have to use those variables if you don't want. I personally don't like using C, so we can use G and F's fine. Or T. Oops, T. So, to start off, the equation is going to look like this. It's going to be a standard linear equation. So you have the function G, when inputted with T, gives you M times T plus P. So you have your slope here, you have your independent variable here, and your y-intercept. So what we need to do is find all these variables. And the best way to start is with 2 points. Just think of this as a graph. You have 2 different points. You have 59 degrees and 76 chirps. So there's one set of points right there. You have 65 degrees and 100 chirps. So there's your other set of points. Do you know the slope formula?
You subtract. I would subtract 76 over 100 and 59. I would write them down in brackets.
Yeah.
Like,
yeah, that's the best way to
like
start.
59 comma 76, right?
Exactly.
Yeah.
And then you start another bracket, and you're going to have 65 comma 100. Now the formula goes y sub 1 minus y sub 2 over x sub 1 over x sub 2. And you're subtracting these from each other. You can do y sub 2 minus y sub 1, but you can do it either way. It doesn't matter which one's first. All that matters is that it stays consistent. Like if y sub 2 is first here, x sub 2 has to be first here.
So let's see.
This is your x, this is your y, x and y. So
right. So 76 minus 100 over 59 minus 65.
no, hold on 1 second. 65 is your x sub. Well, see, 76 is your x sub is your y sub 1. That's your y. Okay, yeah. See, because it's you have to make sure it's constant. So now you just do what that is. You make a calculator.
4 over -6.
Okay, and
So that's 24 over 6. So that is
negative 24 over negative 6.
Right,
So,
so
it's
it's 4.
positive. It's positive 4. Good. So now you have the slope, which is 4, or 4 over 1 if you want to think of it that way.
Right. So now we have g of t equals 4t plus b. So now I have to find b.
Now we find b.
Okay.
So do you know how you're going to find your y-intercept?
By inserting one of these points.
Both of them, actually. Or you're going to insert one of You're going to insert one of these sets of points into it. So,
right, a set. Yeah,
this is your x, this is your y. So this can be thought of as y, because that is actually y. So you have your y value, 76, equals 4, your slope, times your t, which is also known as x, 59, plus b. No, sorry.
And then we just got simple algebra.
No, think of it as a two-step equation there.
So b equals negative 160.
Exactly.
All right. So now I have a whole equation.
So now just piece it all together.
Now we have the answer. Right.
There you go. There's your equation. So that's part A. Now we move on to part B.
Predict the chirping rate at 490 degrees.
Alright, so now it's given you this point. It's given you your x. So now it wants you to find the y. So input it into there. and it's 90. Now solve that like any other math problem. Use order of operations. Four times 90 is, let me just check this. It's 360 minus 160 is 200, yeah. So that's 200 chirps per minute at 90 degrees Fahrenheit. So there you go, that's part B. So now part C.
So now we're just inserting in what 120 here.
Equals, because 120 is your y, right?
T minus 160 plus
Exactly.
160 is 280 equals 4t. 280 divided by 4.
7. There you go. So at 70 degrees Fahrenheit is when it chirps 120 times per minute. So now D, it's asking you find the chirping rate intercept. What does this tell you about the real world? So we already have our chirping rate intercept.
It would be negative 160.
Exactly. Now think of it. Can a cricket chirp negative 160 times? You can't negatively do anything. So what does that tell you? Because think of it this way. Since your y-intercept is negative 160, what is a y-intercept? It's when the x-intercept equals 0. And 0.
So they don't chirp when it's 0 degrees.
Exactly. This is way easier.
I'm faking everything I'm saying.
Tells you that they don't chirp at 0 degrees Fahrenheit.
Okay, calculate the temperature intercept. What does this number represent in the real world?
Alright, so we have our y-intercept, which is our chirping intercept, so now we need to find the temperature intercept. So that means it has to be our x-intercept. So do you know how you're going to go about doing that?
No.
Okay. Well, we can refer back to up here. You know how I said g of t is y?
Mm-hmm.
And the definition of an intercept is when the opposite one equals 0. So that's when y equals 0. So you set the equation like this. 0 equals 4 times, we don't know what t is. T is your x-intercept, because as I said here, that equals x.
Right, minus 160.
That's all.
So, is the whole packet as easy?
Mm-hmm.
Really?
Well, towards the end it gets a little bit more difficult because it becomes decimals. These are pretty easier, they're easier numbers to work with because they're all factors of each other. Alright, so now it's asking us what does that number represent?
That would represent when the cricket stops chirping.
Exactly, because the that's when the y-intercept is 0, which is chirping. So that means if they're not chirping, that's the temperature they stop. Alright, now we're gonna
Plot the graph.
so draw yourself a graph.
What do we have? We have negative 160 and 40.
Yeah, the easiest way to you only need 2 points to make a graph. So the easiest way is to start with your x and y intercept. It doesn't have to be complete.
So y is negative 160 and x is 40. A little bit slow.
Just make sure you cap it. Alright.
What is the slope? What does this number represent? Well, it's rise over run, so...
Well, we know what the slope is. It's 4. That's the slope right there.
Right.
And
4. And it represents the number of chirps per degree.
Exactly.